Right, so in class the other day, we took some data to see if people could actually tell the difference between the regular Oreos and sort of the generic brand version of the chocolate sandwich cookies. So we're taking again, the idea here is that there's no new math in this set of notes. What we're trying to do is make a decision, right? So the goal of what we were doing yesterday was to come up with the idea of, okay, so we collected some data, can people tell the difference between the two types of cookies? So what we're going to do is take this idea that you learned, we're going to talk about the math that we did before, and the whole goal, again, in this chapter is to formalize everything. So we're going to talk about hypothesis testing. Now you've probably heard the word hypothesis from some type of science class that you had before. So our goal here is that we're going to have a hypothesis test is used to answer questions about a population parameter based on information from the sample. So right, we are trying to figure out, based upon our sample of cookies that we did with people, can people tell the difference between the two types? So not just for our sample, but is that true for everybody else? Is that true for the entire population? So every time we do a hypothesis test, there will always be two hypotheses. The first one that we're going to have is what's called the null hypothesis. And we're usually going to label that as H0. And this is the idea that nothing is happening. Generally, this is what's claimed to be true, or what you believe to begin with. So I mean, it's just the idea. So thinking back to the previous video when we were looking at Chantix, right, they told us that they had a 30% success rate. So that would be our null hypothesis. They have a 30% success rate. Now, the goal, as it says here, the researcher generally actually hopes to disprove, or what we call reject, the null hypothesis. So it's what we're believing to be true, but usually the reason we're collecting data in the first place is actually to show that this null hypothesis is not true, and instead, really, this alternative hypothesis is true. And so when we label that as HA. It's a statement that something's happening. It's usually what you're hoping to prove. So for us, like we were trying to show with the Chantix one, you know what, they're over-reporting their success rate. It's actually lower. So we have this goal. Or the idea of what we're doing in class with the experiment. We want to show that people can tell the difference between the two types of cookies. Now we've already seen a couple of examples, and you'll get to formalize the cookie one in class next time. So let's talk about maybe some more boring generic examples to see if that helps tie the idea here. So the first thing I'm going to do is sort of let you know my notation here. So we're going to do coin flipping examples, and I'm going to let P represent my proportion of tails. Now I could just as easily make it be heads. I would just then have to pay attention to what I'm doing later. So no big deal there. Alright, and our first example that we're going to do is going to be like a little game between you and I. So if it's heads, I win. Tails, you win. Okay, so that's our kind of main setup here. Now, how would I think about the hypotheses here? Alright, so generally a pretty standard null hypothesis when we're doing a coin flipping example, right, is that the coin is fair. Right, pretty safe assumption that we make about coins most of the time. Now we're going to do this from your perspective. What would make you worried? At what point would you be upset about this coin? Would you care if there were a ton of heads, like too many heads, too many tails, too many of either of them? Which one is going to concern you, or would both of those things concern you? Well, let's think through it. So from your perspective, if I get heads all the time, you're probably not a very happy camper because I'm winning all the time. Right, versus if there was a ton of tails, you're winning a lot, you probably aren't going to throw a fit if you're winning a lot, right? You're probably only going to be throwing a fit when I'm winning a lot. So your concern, what you are going to be worried about, what you are worried about happening, is that there are too many heads. Or we could think of it as also saying too few tails. Right, same idea. That idea makes sense. Now let's think about how we take that and not have to write this out in words all the time. Let's go up here. We want to use this P. If the coin is fair, what will P be? What percentage of the time should we get tails if it really is a fair coin? Right? We should get 50% tails. Now if there are too many heads, or also known as too few tails, what kind of value would P be? Well, P represents a proportion of tails. If there's too few tails, it's going to be something less than 50%. Right? I mean, even technically, if there's only 49% tails, that's too few probably in your mind, right? So anything less than 50% would be concern for you when it comes to the proportion of tails. Now, a second example from the same idea of a coin flipping, but we're going to pretend for just a moment that we have a game that we're going to flip a coin at a casino. And we're going to do things from the casino perspective here. So what is something we would, again, usually assume? Right, we usually assume, again, that the coin is fair. We will assume that there is 50% tails. Now, when should the casino become concerned? Right, so if they're not playing this little game over here, right, they're just now saying, okay, people can wager so much money on heads, they can wager so much money on tails, they can bet on whatever they want. Alright, so what becomes a problem to the casino is if things start becoming predictable. Right, if they can start picking up on like, wow, this coin is coming up heads a lot more than it's coming up tails. Or the same thing, right, they can notice, like, it's coming up tails a lot more than it's coming up heads. So the problem that's going to happen here for the casino is any time that people could pick up that it's not a fair coin. Right, if people can start predicting what's going to happen with this coin, the casino is going to lose money. If we can't, find out one is more likely than the other, then the casino should still be okay. Now that might make this a little bit harder to figure out how are we going to write what would P be if the coin is unfair. Well, and keep on again, so P is proportion of tails. So would the coin be unfair if it was 40% tails? Yep, because right then it's 60% heads, right? So one is more likely to come up than the other. If the proportion of tails is 60%, is that also an unfair coin? Yes, right, because again, I can still say it's a 60-40 split, just which one was the 60 and which one was the 40 was a little bit different. So at what point is the coin going to be unfair when it comes to proportion of tails? It's going to be unfair anytime that its proportion is not 50%. So we have this not equal to idea. We're going to worry about if there's too few tails, or if there's too many tails, then the coin becomes predictable. As I hope that idea makes sense. The first thing I want you to notice from here is you can actually have the same null hypothesis and a different alternative hypothesis depending upon your goal. So a big thing I'm going to go back up here and say then for the alternative hypothesis, this is generally your goal. This is going to be motivated by the problem. The only way I'm going to ever be able to figure out an alternative hypothesis is by reading the problem and trying to figure out what they are trying to show. Alright, so we're going to work with these two examples and kind of compare and contrast them. One of them is what's called a one-tailed hypothesis test, and one's what's called a two-tailed. So we're going to talk about what that terminology actually means and sort of why it's labeled that way. So let's look back at our example 1. And so since it's on the previous page, I'll go ahead and write it here. So that's where our P was 0.5. And the alternative is that it was less than 0.5. Okay. And a big thing I'm going to do for both of my examples here is I'm going to go ahead and assume that my conditions hold. So maybe drawing some normal pictures here. And so I've got to assume that those conditions hold for me to draw those pictures. Alright, so with example 1, So assuming my conditions hold, I'll have this nice, pretty, bell-shaped curve. It's going to be centered at 0.5, because that's what I'm assuming is true. All right, I'm going to assume that this is a fair coin until I know otherwise. Now, where I'm going to look on this picture depends upon what else is going on up here, more specifically the alternative hypothesis. We're only concerned if there's less than 50% tails. So I don't really care about anything over here at all. I'm only caring about what's going on over here. Now, for example, if I would get 49.5% tails, would you really think there was concern with this coin? Okay, probably not. I'm going to have to be far enough below that 50% before I'm going to start getting concerned. How far below? I know it's going to be somewhere sort of over here. If I'm anywhere along this part of the line, I'm going to be concerned. Now, what exactly is this number along the bottom? Well, as we've seen in previous examples, so I'll actually go back to this from our last video. Right, I mean, in order for me to put these numbers along the bottom, I had to know the standard deviation. The standard deviation is affected by sample size. So until I know how many times I'm flipping the coin, I can't really put a number along this bottom. But it's going to be far enough below, and this value is going to be determined based upon sample size and different things like that. But I'm going to be far enough away. Now, I'm not worrying about up here. Remember, we're looking at proportion of tails. You win when it's tails. You're perfectly fine if we're up here. So there's no concern for you if that were to happen. But there is concern over here on the left-hand side. So what this represents is that these are values that are unlikely to occur if the null hypothesis is true and support the alternative hypothesis. Right, so they're unlikely because they're far enough away from the mean, but they also are supporting our alternative. We're only caring about the small values over here. We could care less about what's going on up here. All right, let's see if that would be different for example 2. So for example 2, our null hypothesis was the same, that p was 0.5. But our alternative was that it was not equal to 0.5. Again, assuming my conditions hold. Gonna have my pretty little curve there. Same null hypothesis, so we're still assuming it's a fair coin. Alright, so where would it be an unfair coin? Like, right, where is it not equal to 0.5? Well, if I'm anywhere but here. But again, if I get like 49.5% tails, I'm probably not going to think it's an unfair coin. If I get like 50.5% tails, I'm probably, so if I'm pretty close to this 0.5, I'm probably going to still think it's a fair coin. I'm going to be far enough below this way. So if I get far enough down here, I'm going to be concerned. But I'm also going to be concerned if I get way too far up in this way, right? Because I'm worried about if I can pick up on the fact that it's a biased coin. So if there's way too many, if there's too few tails, and I can pick up on that, the casino's going to start losing money. If there's too many tails, people can start picking up on that, and they're sure going to start losing money. So if I'm on either extreme, we're going to be concerned. So if I'm in either of these areas, these are now our unlikely values to occur if the null hypothesis is true and support this different alternative hypothesis. So the first thing to notice is my picture is going to look different if my alternative hypothesis is different. If it was this one, I was only concerned about this side. With the not equal to, I was concerned about both sides. So then talking about this idea of the one-tailed versus two-tailed idea. Right, this is your one-tailed because I'm only looking at one side of the picture. And this is going to be your two-tailed. So we're looking at both sides of the picture. So that's the idea. Right, thinking about sort of a real-life application of this one-tailed versus two-tailed test. So some of you may notice that in class, I drink Dr. Pepper, my diet Dr. Pepper a lot. So there's, they claim a certain amount is in there. So generally I have like the 16.9 ounce bottles of my diet Dr. Pepper. Now, if I want to start worrying about a hypothesis test, right, it's a pretty good assumption there's 16.9 ounces in my bottle of pop. Pretty reasonable one, that's what they tell me. But maybe I start getting my pop and I feel like, I'm getting ripped off. There's just not enough pop in here. Right, as a customer, I'm only going to be concerned if you're not giving me what I'm paying for. Right, if there's anything less than 16.9 in there, I am going to be an upset customer. So as a customer perspective, with that scenario, I would have a less than type idea. Right, I don't want to be ripped off as a customer. Now, if I was looking at it more from the business perspective, they want to monitor how much pop they're putting in that bottle. They're going to have to worry about both sides, right? One, they don't want to have to worry about upsetting the customer. If you put too little in there, I'm going to be upset. I'm not going to write an angry letter. I might stop buying the diet Dr. Pepper. That's going to be a problem for them. But also, if there's too much, there's a couple different issues. One, if the bottles start overflowing, obviously that's a mess that they have to clean up. But also, there's the profit, right? If you say 16.9 ounces and you put 17, that doesn't seem like a big deal until you stretch over all those bottles that they're doing, right? So they're going to be losing profit if they put more in that bottle than they said they were going to. So depending upon the perspective that we're coming at, we can have a completely different alternative hypothesis depending upon what our goal is. So when we get to class, the goal is going to be for us to figure out first, what should the hypotheses be for our chocolate sandwich cookie experiment? So that's where we will start in class together.